Hey guys, so today we're going to be talking about the effects of encapsulation on the viability of probiotic L. acidophilus in yogurt. So we first define what are probiotics. So these are live microorganisms which when administered in adequate amount confer a health benefit on the host. So we are highly encouraged to consume probiotics to be able to maintain a balance among the good and bad bacteria in our digestive system. So in turn, these are the health benefits that we can acquire. However, the problem with consuming yogurts is the low viability of probiotics after refrigeration or after some time of storage. And as is stipulated by FDA, in order for a probiotic product to provide optimal health benefits to the host, its count shall be at least 10 raised to 6 colony forming units per ml up to the end of its shelf life. Only then can the probiotic be considered as viable, and only then can it be able to confer health benefits to the host. So the factors in viability include the low pH level decrease and a warm storage temperature, which are detrimental to the survivability of probiotics. So one solution gaining prominence nowadays is encapsulation, in which tiny particles or droplets are surrounded by a coating. So as you can see in the illustration, encapsulation provides a non-permeable layer of protection from the adverse conditions in the yogurt environment. So this is the encapsulating wall material. Inside are the probiotics, and along with it are the prebiotics. So usually probiotics and prebiotics are consumed together, and prebiotics is a substrate that is selectively used that also produces health benefit on the host, except that these are substrate and the probiotics are live cultures. So the significance of the study doesn't just include the optimization of the health benefits, but also helps the yogurt manufacturers in complying to the standard probiotic count. So just like in Jayalalita's study, I have prepared 3 variations. So there are 2 encapsulation treatments prepared and one in which the probiotics are not encapsulated. So this is the control. So 2 encapsulation treatments are prepared to assess the effectivity of another wall material, which is the gelatin. So as you can see here, this is our main wall material, the sodium alginate, and our prebiotic is the starch. So as for the methodology, so of course it consists of one phase only. So we start first by acquiring an active form of L. acidophilus from the Philippine National Collection of Microorganisms. So the culture was propagated and subcultured using 140 test tubes containing MRS broth. So while it was being propagated, we prepared the yogurt mix, and this is the source of the yogurt culture. So 2 yogurt mixes were prepared. One is for the encapsulation treatment and one is for the control. So for this yogurt mix, the a reserve cup subculture was directly inoculated at the rate of 1%. And as for the other mix, of course, we harvested first the probiotic biomass and encapsulated it through extrusion method. So of course, these are the 2 different kinds of wall materials for the encapsulation treatments. And the beads formed from the extrusion method are dispensed to the yogurt lots. So the yogurt lots are then stored until it was analyzed. So in enumerating the samples, we use a differentiating agent, the sodium azide, so that we can only isolate the Lactobacillus acidophilus. And the whole study consists of 7 days. Each day we analyzed the yogurt samples and we allotted 5 days for the sensory evaluation. So these are some snaps from the study. So these are the ingredients for the wall material. This is the culture, the dispenser use, the probiotic masses, and the yogurt lots. And these are the beads that were formed. It's kind of faint, but it is here. As for the results and discussion, we start first with viability. As we can see here, all the probiotic counts have declined, and CTR has the highest growth decline at the rate of negative 46.54%. So there are also significant differences among the counts, specifically between EASG and CTR. This just means that encapsulation with alginate, starch, and gelatin significantly enhance the viability of probiotics, but encapsulation with alginate and starch alone is not as effective. As for the pH, as you can see, there is an initial increase in pH first for EASG and EAS, followed by a decrease in the counts compared to the pH level in CTR, which remained only at 4.8 to 4.9. So of course, there are significant differences among the counts, and this means that yogurt with encapsulated probiotics have higher pH levels than yogurt with non-encapsulated probiotics. So, yogurt as a product of fermentation attributes the decreasing pH due to the conversion of the lactose content into lactic acid by the lactic acid bacteria in the yogurt. So, encapsulated probiotics have limited metabolic activities, thus slower rates of post-acidification. It's because it takes longer time for the lactic acid to permeate. So that's why they have higher pH levels. As for the titratable acidity, so as you can see, there are no significant differences among the TA levels, which means that encapsulation has no significant effects on the titratable acidity of yogurt. However, since there is a slower post-acidification rate in the yogurt with encapsulated probiotics, in turn, EASG and EAS have lower titratable acidity values. As for the TSS, so as you can see, there are significant differences among the TSS levels, and this means that yogurt with encapsulated probiotics have lower TSS content. So a high TSS content is related to lower probiotic viability due to slower fermentations of sugar into lactic acid. A high TSS is also related to low pH since lesser sugar compounds are converted to lactic acid. So as for consistency, as you can see, there are no significant differences among the consistency levels, and this means that encapsulation has no significant effects on the consistency of the yogurt. But EASG has the lowest consistency, and along with EAS, they are notably lower compared to CTR. And this could be attributed to the thickening natures of the encapsulating materials, for instance, the gelatin and the sodium alginate. As for the sensory evaluation, so in sensory science, the sample needs to have a score of 5.5 to be acceptable, and all samples are organoleptically acceptable by the end of the study. So as for the correlation of the parameters, by the way, we're gonna base on the EASG data because EASG exhibits the most favorable or ideal results. So we found that viability is negatively related with TAN consistency and has no relationship with pH and TSS. Meanwhile, pH and TSS, TA and TSS and consistency are negatively correlated. So in conclusion, this study proved that encapsulation of probiotics with the addition of gelatin significantly enhances probiotic viability, but encapsulation without gelatin is not as effective. Both treatments, however, have significant effects on the pH and TSS, but have no significant effects on the TA and consistency of yogurt. In addition, encapsulation does not affect consumer acceptability. So this ends the presentation. Thank you so much for watching.